And good morning, everybody, to day 2 of the Lunar Surface Science Workshop on structuring real-time science support of Artemis crewed operations. So Kelsey Young and I are the chairs, and we welcome you back. We want to start off today with a quick rundown summary of yesterday's, mainly the breakout sessions. So I've got a couple of slides, and then I'm going to hand it over to Kelsey to talk about the breakout that she chaired. So let me get into presentation mode here. All right, can everybody still see that? I hope so.
Yes, we can.
All right, thank you. Okay, so breakout 1, these were the leading questions at sort of the high level. The breakout that I chaired, this one, ended up focusing mainly on the bullet point that is highlighted there. So what are the best ways to integrate engineering, mission operations, and science in the preparation for a mission? So we came up with several findings in what I've lumped into 3 categories. And I've actually highlighted some words up there in the guiding question that weren't in the original one, and that's because there's a few interesting points that came up that I'll talk about in a minute. The first category of findings was in the realm of tool development. So there's a number of tools that probably need to be developed starting soon. Mainly to work with data. So building tools to incorporate existing data sets as context for data acquired during the mission. So things like LRO, other data sets for contextual information that the science support team can use. Tools to enable participation among the science team. So collaborative tools, things that enable distributed teams. Tools, workflows, and data capabilities for specific data streams that we're expecting to get back from the moon. And going along with this, sort of before that really, is to identify what tools and what science is enabled by those tools, and identify how and where to do high fidelity tests of those systems. And a very important point is to get scientists involved early on in that development work, both for tools and software. And then finally, data and visualization and interaction tools. So during the mission, those kind of tools are going to be invaluable. And so in mission preparation, those tools need to be developed. The second set of findings was in what I call sort of personnel development. So an important point here is to engage people who can wear many hats, so it can be very flexible. Scientists who can also interact and engage with engineers and operational folks, because those are the sorts of skills that are going to be needed by everybody really who's involved with the science support team. Get scientists involved early on in defining tools, science goals, exploration sites. And then for the entire team, do as many simulations as possible in real time and as early as possible. Part of this is embedding scientists in operational simulations, engaging them in part task training with items like suits, hardware. That way the scientists have some idea, some recognition of what the engineering and operational side is, and also vice versa. So it's important to get the operational management engineers and scientists in the field, for instance, together. Maybe even before that, doing simulations of various degrees of fidelity to increase familiarity among the entire team, because ultimately the team needs to speak the same language, understand each other's job, and really it's a trust building exercise that really is important in the run up to a mission. The last set of findings are sort of what I lumped into an other category, sort of a catch-all. The first relates to the highlighted words up there. So management and funding are important. And so it's important to integrate that into the planning for missions. Relatively small investment now in things like analogs, for example, will lead to mission affordability, readiness, and success later on. And then for public outreach, someone made the point that we won't have a sustained presence on the moon without winning the hearts and minds of the American people, decision makers, and so on. I'm running out of time here. I want to give Kelsey enough time. So let me go through these real quick. So integrating non-science aspects of surface operations into planning and decision-making, being prepared for how science support will evolve over time from short sortie missions, which might be run differently than longer-term missions. So flexibility, just as we have flexibility in traverse plans at sort of the larger scale, the programmatic scale, we should be prepared to be flexible. And then there was some conversation about the Capcom role, which I'm sure today we will have a more detailed discussion of in our breakout rooms today. And then finally, question of how to manage a huge amount of data. And again, that's part of today's breakout discussion also. All right, Kelsey, over to you.
Great. Look at that timing. Okay, so breakout 2 was focused on isolating lessons learned kind of in the 3 key areas we heard about all day, but especially in the second session yesterday, Apollo, Mars, and ISS. So without further ado, Jose, next slide, please. So first, some findings from kind of what worked well from Apollo and what are the kind of resulting, findings and recommendations for building toward Artemis. Get early career scientists involved. Obviously, Apollo did that very well, and we really want to find ways to encourage the next generation to get involved. We'll talk about that as well in the second breakout today for strategies for that. Want to highlight the point that real-time tracking data is critical for science team situational awareness, especially given kind of greater available technology now than we had during Apollo. Someone brought up the point that we want to investigate if any of this can be controlled from the ground to offload the crew, which would enhance situational awareness without burdening the crew with that impact on their schedule. We want flexibility at all levels in executing traverses. Want to make the point that we should complete objective-driven exploration completed by really highly trained crew that enables them to, react autonomously with some support from Earth, but relying on that really heavily trained and highly trained crew. We really need to balance well-established priorities against the discovery of the moment, and that should be kind of the spirit of exploration. Want to make the point that Apollo astronauts served as the field PI and therefore were able to take ownership over science objectives, which worked really well. And a theme we heard all day, and Jose just briefed it as well, the relationship between the scientists and sort of the rest of the flight control team really needs to be incredibly strong. We can use simulations to build trust. We can build in new support tools to engage with the broader team. We're all used to doing that here in the COVID universe. And we really need to cross-train scientists, engineers, and flight controllers to speak each other's languages. Next slide, please, Jose. Moving on to Mars, want to make the point that ops and the decision-making cadence is much slower for Mars than it is for Artemis crews, but there are still a lot we can learn about science and engineering synergism. A phrase Ashwin used, which I really liked, was strategically planned but discovery responsive. And we can learn a lot from the Mars community on the fact that they have really wide multidisciplinary teams of scientists and engineers that number, in the 600s of people. And so looking at strategies on how they organize those really broad teams are really critical. To give a couple, they really spoke to the need this sort of cross-discipline synergism and learning to speak each other's languages. And a couple interesting points that I won't go through all of these now are that they have a science operations working group that's chaired by a scientist with sort of the flight director equivalent looking over their shoulder, and also that there are organizations by science themes like sedimentation and stratigraphy is one example, and also through specific campaign leads depending on where they are in the traverse. Scientists are embedded within engineering teams. This is a theme that's come up over and over again, and I know we're going to hear a lot about it today in the analogs conversation. And there was also a point made that scientists and engineers physically co-located, like sitting next to each other and looking over each other's shoulders, really enable each other to react real time to discoveries rather than remotely connected but not physically co-located. And there's also some lessons learned about the data products and mapping teams from the Mars community, and that some of these ops products I think we can learn a lot from for science operations for Artemis missions as well. And there was also a recommendation for detailed mapping teams real time, potentially split into tactical versus strategic mapping teams. That goes back to the Apollo lesson learned of really wanting to maintain that situational awareness over where the crew is at any given time. Next chart, please. And finally, we want to leverage, of course, lessons learned from station operations, which is, having people in space right now today, into Artemis. So a lot of these came from Jackie Kagi, who presented yesterday, and she highlighted the point that the ground IV talks to the crew, but the Capcom remains the prime communicator for the rest of the IV crew when crew is EV. There's some, I think, more thinking we as a community need to do to draw that lesson learned into Artemis. And there were some points made about the interaction between the flight control team as a whole, including scientists with the crew, about if they're proceeding normally, if ops are proceeding normally, the flight control team is typically in receive mode, which means they're relying on the highly trained crew to do their work. But during off-nominal operations, I think we as a science community need to think about what kind of science contingencies there are and how to train the crew for them and how to train the flight control team for them. We should be ready for get-ahead tasks for science. I think this is something we all could be excited about, the opportunity to do more science. And we need to think more about, and breakout 2 today, we'll talk about this, the clear direction and science decision-making authority. Where does the buck stop there? We can learn a lot from how to do multidisciplinary science on ISS. However, remember that a lot of this direct scientist engagement on ISS now is done inside the habitat rather than the pressurized EVA environment. So I'll stop there and turn it over to Marie Henderson, who will be chairing the first session today. And we really look forward to another day today of a lot of great community engagement. And Jose and I want to thank you guys for really jumping in and participating heavily all day yesterday. And we look forward to more of that today.